So in this demonstration, I'm going to explain to you how to make any conversion using a process called dimensional analysis. So dimensional analysis is a process used in science and engineering to convert units when you kind of have a convoluted path to get to where you want to be. So we're going to start out with some simple examples, just a one-step process so you can understand how that all works, how to set up the math, how to set up your conversion factors, and then we're going to go ahead and do a little bit longer one so you can understand why this is important. So this first example is going to be one that you can probably do in your head. How many inches are there in 3 feet? So in your head you think, all right, there's 12 inches in a foot. I got to multiply that by 3, so that's 36 inches. So how would you set that up if you're doing dimensional analysis? That is right on the bottom here. So 3 foot times, we're multiplying what will be fractions, times 12 inches per foot. And let's see how this looks, go through all the steps of dimensional analysis. So we've got our setup here, which is 3 feet times 12 inches per foot. So canceling units. We know just by the laws of multiplication, of fractions, that what's on top and what's on the bottom as far as units, they'll cancel each other out. So if you have something similar on top and it's the same on the bottom, those will cancel each other out. So that's the power we're harnessing with this process of dimensional analysis. So in this example, we're crossing out feet. So we've got 3 feet, cross that out because there's also feet on the bottom. And that leaves us with only 1 unit remaining, and that's inches. And that's what we want, because we want to know how many inches are there in 3 feet. And this is something we did in our head, but I'm just showing you how we're setting this up. And then by the math of multiplying across the fractions, we know that we multiply everything across the top, 3 times 12. And then we multiply everything across the bottom, which is only 1 here. And that's going to look like this. So 3 times 12 on top is going to equal 36. We've only got the number 1 on the bottom. So we carry that across. So it's 36 divided by 1, which is going to equal 36. And then we'll take our units. Sorry, I'm going to go back here. We're going to take our units and carry that over. So the feet are gone, but inches remain. So then our answer will be 36. We're going to carry this down, 36 inches. So we did our units, and we saw that we only had inches remaining once we canceled out the feet from the top and the bottom. And then we multiplied across and divided, and we had 36. Carried our unit, 36 inches. So that was easy enough to do in our head. We're going to do another simple example just to see that again. Repetition leads to mastery. So how many eggs in 64 cartons? So what do we know? We know that our answer must be a count of eggs, because that's what it's asking us. How many eggs? And then every carton holds 12 eggs. So this serves as a conversion factor. So 64 cartons, we're setting it up for dimensional analysis like we have in the previous example, times 12 eggs per 1 carton. All right. So when we cancel our units, cartons on top, cartons on bottom, so those cancel each other out. And that leaves us with only eggs. So that satisfies our point 1 for what do we know. Our answer must be an account of eggs. Perfect. So then if we know that our units are correct, which we just did by canceling out cartons and seeing that we only have eggs remaining, that satisfies part 1, we can be pretty confident that our math will follow and also be correct. So let's just go through and do our math. So it's going to be set up like this. 64 times 12, so that's 64 times 12, and that's on top. So we just multiply every number on the top, and then on the bottom, all we have is 1. So when we carry it through, that's 768 divided by 1, which equals 768. Now we carry the units, and that's 768 eggs. All right. So that was an easy example. We probably could have done that one in our head. But the reason we use dimensional analysis, or why we set things up in this particular way, is because sometimes in the sciences we come across problems that, it takes multiple steps. There's multiple conversion factors. And instead of going and doing simple conversions like this in steps of 2, just 2 conversion factors, we might have to take 3 or 4 steps to get to where we want to go. And instead of having to do one equation of 2 conversion factors and then again another conversion, carry that, and then do another conversion and another conversion, another conversion, we can just line them all up in a row. And then we just do the math, we cancel all the units, and we know that it's going to be correct. So this next example is going to be a little bit longer, and you'll really start to see the power of this dimensional analysis. So, a lot of words here. Let me just talk through them. So let's say we have a solution of water that has 600 grams of sodium per gallon. All right, you just had a bucket of water that had a gallon in it, and you took 600 grams of sodium, threw it in there. All right. That might not be safe now that I'm thinking of it, but that's just our example here. All right, we want to know how many parts per million this is. So what do we know? We know, starting with a conversion factor that was given to us, 600 grams of sodium per 1 gallon of solution. So that's a conversion factor. That was in our problem. They set that up for us. And we know, you might know this, might not know this off the top of your head, but we know that parts per million is equivalent to milligrams per 1 liter. And that's true because there are 1 million milligrams in 1 liter. So if we know how many milligrams of something is in a liter, we know that there's that many parts per million. All right, so what else do we need to know here in order to get to where we want to go? So we want to go from 600 grams of sodium per 1 gallon, and then we want to get that to milligrams of sodium per liter. All right, so that means there's going to be some intermediary steps here. All right, so what do we need to know? We need to convert grams to milligrams, as we're dealing with mass. And then we need to convert gallons to liters. All right, that's our volume. All right, so easy enough. All the information is at the click of a button on the internet. So I went on to the unit conversion for Google, and under mass, found grams. 1 gram is 1,000 milligrams. All right, so that's a conversion factor. So I just set that up like this, 1,000 milligrams in 1 gram. All right, and then how many gallons in a liter, or how many liters in a gallon? All right, so volume, I found volume on this unit converter for Google, and I wanted to know, okay, I've got 1 gallon, how many liters is that? And then it gave me 3.78541 liters per 1 gallon. All right, so that's a unit conversion, or a conversion factor. So we've got 1 gallon per 3.78541 liters. All right, I think I've got what I need now. So I'm going to set this up. I'm going to set this up into an equation just like we did before, where we want to multiply across, we want to cancel the units, and then this will help you see the power of what we're doing here. All right, so this is set up now. We pulled these off of Google from their unit converter tool, which you can just find by going into Google, typing unit converter, and it'll pop right up. So I set this up. 600 grams of sodium per 1 gallon. And I know that I want to cancel units to where I get rid of gallons and I get rid of grams. So I preemptively made sure I had gallons on top here because I have gallons on the bottom with what we were given. And I want to get rid of gallons, which means I need to have gallons on top somewhere so that this can cancel out. So now I've got 1 gallon per 3.78541 liters. And then now with the grams, I want to cancel out grams and end up with milligrams on top. So there's grams on top here, and now there's grams on the bottom. So we know those will cancel out, and that'll leave us with milligrams on top. So does this give us what we want? Let's check it out. Let's cancel our units. It does. So grams canceled out. There's gram on top, gram on the bottom. Those cancel out. There's gallon on top and gallon on bottom. Those cancel out. So what's that leave us with? Sodium, milligrams, and liters. So milligrams of sodium is on top and liters is on the bottom. So will this give us the following units? Milligrams of sodium per liter? Yes, it does. So we set it up right. We know that we've set this conversion up correctly. Now we're going to have to do some math, right? We know we've got the units right. Now we just follow the rules of multiplying fractions. So what's that look like? That looks like multiplying everything across here, and then multiplying everything across here, and then dividing the product of the top from the product of the bottom. So let's do this. The top is, we've got 600, 1, and 1,000. We multiply those across, that gives us 600,000. Now we go to the bottom, it's 1 times 3.78541 times 1, and that's going to give us 3.78541. So now we're going to divide these, and that gives us a value of 100,000 or 158,503.3. Now I'm going to check out my units. I'm going to carry those over, and that gives us our answer of 158,503.3 milligrams of sodium per liter. So that's how many parts per million we have, and that answers our question. So you can see that if maybe you could do parts of this in your head. You could say, I'm going to convert from grams to milligrams, and that's like one step that you do. And then you convert from gallons to liters, and that's another step you do. But now we can just do it in one step using this process that is called dimensional analysis, and that'll give us, that'll make our work more efficient. And we know that if all the units cancel out to where we want it to be, that we're probably doing the math correctly. So go to my next video of how to use this dimensional analysis calculator online tool and get a feel for it. And you can play around with it, and you'll see that it's pretty powerful. All right, thank you so much.